This is a lesson on finding or identifying the greatest common factor between two monomials. So we're going to start with just regular constants here. So just values, numbers, integers here, 52 and 64. Option 1, you can literally just factor the numbers. You can do 1 times 52 here, which is also 2 times 26. It's also 4 times 13. There are no other factor pairs for 52. Do the same thing for 64, which is 1 times 64, 2 times 32, that's supposed to be 2, 4 times 16, and 8 times 8. Now I'm looking for a number that's the same in here. So I have several factors that are common. There's a 2, and there's a 4. So 2 is a factor of both, but 4 is larger. So we would identify 4 as the GCF. That's option 1. That's how I typically do it. Option 2 would be to do the prime factorization of each. So we're going to take 52. I like a factor tree, so 2 times 26. 26 is 2 times 13. So really 52 is 2 squared times 13. These are the same. 64. I'll just do 8 and 8, which is 2 times 4, which is, this one's 2 times 4. So it's really just a bunch of 2's. This is 2 to the 6th power. Now what we're looking for are all of the prime factors that they have in common. And here we have a 2 squared. Here, 2 to the 6th, if I break it apart as a 2 squared and a 2 to the 4th, they have a 2 squared in common, which is the same as the GCF of 4. So you're identifying all of the common prime factors and then multiplying those. So let's see how this works when we have variables included. So again, we're going to find the GCF between 72x squared and 16x to the 5th. First of all, let's look at the numbers. Okay, 72 is 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. 16, I'll do this in a different color here. 16 is 1 times 16, 2 times 8, and 4 times 4. Looking through these numbers, it looks like 8 is probably the largest factor here in both. So I know that my GCF is going to contain an 8, but what about these x squared and x to the 5th? Well, there are 2 x's here, there are 5 x's here, so clearly there are 2 in this one, right? So I'm going to have x squared as my GCF, as part of my GCF, so it's 8x squared. Okay, both of these monomials can be divided by 8x squared evenly. If I looked at this from a prime factorization, 72, so 2 times 36, this is 2 times 18, this is 2 times 9, that's 3 times 3, so it's really 2 to the 3rd times 3 squared times x squared. So this piece has a prime factorization of 2 to the 3rd, 3 squared, x squared. And if I did the same thing for 16, 16 is 8 times 8, 4 times 2, 4 times 2, 2 times 2, 2 times 2. That's definitely wrong. Wow. I was like, that's a lot of 2's. How about 8 times 2? And then 8 is 2 times 4, and 4 is 2 times 2. So we have 1, 2, 3, 4, 2. So it's 2 to the 4th, and then the x to the 5th shows up. So really what I'm looking at is I'm trying to see which of these occur over here. And if I broke the 2 to the 4th up into a 2 to the 3rd times a 2 to the 1, and I broke up the x to the 5th as an x squared x to the 3rd. Remember, if you're using your properties of monomials, if you multiply like bases, you add the exponents. So if you wanted to reverse that, you could break them apart into 2 pieces that add up to the 5, or 2 pieces that add up to the 4. Now I can clearly see that this 2 to the 3rd shows up in both, and this x squared shows up in both, and that's my GCF. 2 to the 3rd, x squared, 2 to the 3rd just happens to be 8. So on this one, pause, give it a shot, see how you do, and then unpause to watch the rest of the video. I'm going to start with the prime factorization. I know 18 is 2 times 9, which is 3 times 3. So it's 2 times 3 squared times x times y squared is that whole piece. 48 is 3 times 16, which is 4 times 4, which each of those is 2 times 2. So it's really 2 to the 4th times 3 times x squared times y to the 1. And that would be an x to the 1 there. So I'm looking for things that are the same. Now, if you haven't really understood the whole prime factorization and how it works, and another way to look at it is to literally list all of the factors exactly once. Okay, so we have our 2, we have our 3 squared listed out, we have our x, and we have our y squared listed out. And then just like that, for this other one, we have 2 times 2 times 2 times 2 times 3 times x times y. And I'm going to, in this case, just highlight the ones that they have in common. So there's 1, 2 here, matching up with 1, 2 there. I'm going to take this 1, 3 with this 1, 3. I have an x here, an x there. I have a y here, I have a y there. So we end up with each of those highlighted numbers occurs once in the GCF. So we have 2 times 3, which is 6, and the x times the y, which is just xy. Now later on, in a subsequent video, when we're actually going to factor out the GCF, we would then do something with the remainder of each of those. Okay, but that's a different lesson for a different day.